wrapping up solutions and solubility by discussing acids and bases. So a little bit of theory based on acids and bases. And we know that we've got, there's a fear about acids and bases when it comes to the lab. And of course, there are acids everywhere, like even in the foods, right? So here, let's look at a few common acids and bases that we actually have in the household, right? We've got the citrus acid or citric acid that's found in fruits, okay? Ascorbic acid, we've got in dairy, right? Lactic acid in vinegar, acetic acid, carbonic acid here in soft drinks, underarm odor sprays or the sticks, okay? We've got acids. In terms of bases, right, we've got oven cleaners, baking soda, glass cleaners, right? So we've got these things, and of course, we always want to make sure that when we handle some things that, of course, like an oven cleaner, right? You want to make sure that you're using the appropriate, safety gloves, right? The rubber gloves that are usually associated to cleaning. Now, let's look at acids, okay? So just kind of recapping, right? If you think about anything, foods, drinks, right? Lemon juice, right? Acidic, tastes sour. Okay, they change color when we use an indicator, right? So for those who remember the litmus paper test, right? Red, right? We think of the D for acid, not really the best one, right? But think of for the next one. So red will stay red if it's an acid, but also blue litmus paper, okay, will turn red in an acid. Okay, so you can use red or blue litmus paper. Now for bases, they taste bitter, slippery feel. Okay, there's also a color change when using indicators. Now, here's the thing, right? If you're using blue litmus paper, it will stay blue, right? So we think of blue for base. But now, if we were to put red litmus paper in, that red litmus paper will turn blue if it's a base. Other indicators, right? We've used phenolphthalein in the lab. If the pH level, the pH is between 0 and 8.2. So we're going from acidic to slightly basic. Right? Phenolphthalein will stay colorless. Anything beyond that, right? So when we, so anything that's greater than, let's say, a pH of 8.2, right? We see that fuchsia color. Okay, remember that pinkish color that we saw in the lab. So usually it's with something that's basic. And so when we were looking at the one that we did in our lab, remember that when it turned pink, right? We used sodium hydroxide. Right? So we used sodium hydroxide. Sodium hydroxide is a strong base. So obviously it was going to change into that pinkish or that fuchsia color. So most bases will turn that color. Acids will actually remain colorless. Another property that can be used to distinguish acids from bases is their conductivity in solution. So if we were to hook up a power source here, and we've got our little light source, right? Because there are ions that are formed in solution, right? The dissociation. Remember when we looked at how something like HCl can dissociate into the following ions, right? So these ions can help carry that charge, right? That can cause the light source to light up. Right? So aqueous solutions of acids and bases conduct electricity, right? So this is proof that ions are present in acidic and basic solutions. So if you had something that was acidic, something that was basic, you would be able to have the light shining. Of course, if you use something that was neutral, right, like water, there aren't really any ions that are forming, right? So you're not going to get the light to shine, right? And of course, the brighter the light shines, the more concentrated the ions are. right? Because remember, the more ions that are present in the solution will allow for a brighter, right? If the light, that was shining wasn't as bright, it was dim, right? Then you knew that the concentration of the ions wasn't as strong. Some observable properties of acids and bases. So if we look at acids and bases, their taste, so we know is sour, one's bitter. Electrical conductivity, well, they both conduct electricity. In terms of feel, right, of course, we would never really want to touch, right, any acids that we're unaware of. Of course, you can touch your, soda pop or vinegar might spill on your fingers. But if something was considered acidic, there's really no feeling to it. Right? It just kind of feel like a regular liquid. But anything that is basic or alkaline feels very slippery. Now, some other properties. In terms of reaction with litmus paper, right? Remember what we talked about? Red for acids, blue for bases, right? So, it turns blue litmus paper to red, right? Remember what we said? So if we were putting blue, even though blue is for basic, right? If we're putting blue into an acid, we're changing that blue to red, right? Or if we're keeping it red, it'll stay red. But for bases, it'll turn the red litmus paper blue. But if we put blue litmus paper in it, it'll stay blue. Okay. Reaction with active metals produces hydrogen gas, right, for acids. And for bases, do not react when we're mixing with. So think about in your acid-base reactions, right? In most acids, as we say, start with the hydrogen. Most bases contain the hydroxide. If we're combining a metal, right, with the base that contains the hydroxide, right, we're just going to displace the other metal. So there's really no real reaction that will actually occur because you're still keeping that basic solution. All you're doing is just creating a different type of base. Okay, and we're going to talk about the OH. Remember how we said hydrogens are the hint for acids, hydroxides are the hint for bases, but there are some exceptions to the rule, and we're going to see that today. Reaction with carbonate compounds, right? Acids will produce carbon dioxide gas, while bases will not react.